Good morning all. Okay, today I am going to give a brief introduction on a wonderful topic which is called machine learning, and I think you all know about something about artificial intelligence, machine learning, data science, all these things, right? Okay, so before starting, you all may have a confusion that what is actually machine learning, or what is the connection between data science, what is the connection between machine learning and artificial intelligence, what is data mining, what is big data analytics. All these things are actually messed up together. Okay, so before starting machine learning, we have to make a clarification that what is machine learning and what are the connection between artificial intelligence, data science, machine learning and all those things. Okay, so as you can see, the artificial intelligence is one of the prominent domain in computer science. Okay, so what do you mean by artificial intelligence? From the word itself, artificial intelligence, we know that computer is a dumb machine, right? Okay, computer can only work with our own instructions. Okay, there is no intelligence for computers. Okay, so artificial intelligence is a branch deals with how to make intelligence to a machine. How to make intelligence to a machine. Okay, and it has a broad domain. It is a broad domain, and there are so many subdomains in artificial intelligence. Robotics is one of the subdomain of artificial intelligence. Likewise, we have game theory. Okay, natural language processing, and one such subdomain is machine learning. Okay, one such subdomain is machine learning. So machine learning is nothing that we are trying to make machine learns. Okay, we are trying to make the machine learns. Okay, and there are so many models or so many algorithms exist for doing machine learning. Okay, one of the important or the prominent algorithm is artificial neural networks. Likewise, we have naive-based machine learning, regressions. There are so many algorithms exist for machine learning, and neural networks are one such algorithm. Okay, one such algorithm. And if you are doing machine learning with neural networks, then we are actually learning, or we are actually making the machine to learn like our neural networks in our brain. Okay, so there are so many models or so many variations in the neural networks, and one such model is called deep neural networks. Deep neural networks. And if you are doing machine learning with deep neural networks, then we will call it as deep learning. We will call it as deep learning. Okay, so then what is data science? Data science is actually deals with a large amount of data. Okay, so what we can do with data? Can you give an example? We can infer so many things from a collection of data. Suppose you have a data from a supermarket. Then by analyzing the data, you can find out which is the most selling good from that shop. Okay, or the association between the goods. That is, if someone is buying a bread, there is a probability to buy a jam. Okay, you can find such associations. So we can do so many things with data, and the branch that deals with data is called data science. Then what is the connection between this data science and artificial intelligence? We are using artificial intelligence techniques for mining or for finding or analyzing data in data science. Okay, and big data is another thing. That is actually, do you think that big and large is same? Is big and large is same? No. Actually, the large data means the volume is large. if the amount of data is high, then we can say that it is a large data. But big data is another thing. Big data deals with 4 V's, that is volume, variety, veracity and variety. Okay, volume, velocity, veracity and variety. Okay, suppose we have a large amount of data, we can say that it is a big data. If we have different variety of data, suppose we have a surveillance system and we will get data from which all sources? From camera, from audio, from sensors. We have a different variety of data, and the volume is also a concern. The velocity is also a concern. If the data comes in a high velocity manner, we can also call it as a big data. Okay, in big data also we are actually using machine learning and artificial intelligence techniques for analyzing the data. So we can directly go to the machine learning. In the first slide we are actually defining what is machine learning. Just read it. Learning is any process by which a system improves performance from experience, or we can simply call as learn from experience. Okay, what is actually learning, or what is actually doing in machine learning? Learn from experience. Okay, I will illustrate an example for that. Suppose you are newly in this world. Okay, newly arrived in this world and you don't know anything in this world. You don't know anything in this world, and I am your companion. Okay, I am your companion. So I am showing a red color shirt. I am showing a red color shirt to you and saying that this is a shirt. So how will you perceive it? How will you perceive it? The shirt will have a particular shape. Okay, and it will have red color and it will have this much size. Okay, then again I am showing the same size, same shape and yellow color shirt, and I am asking that what is this? Is this a shirt? How will you reply? No, because the color is not red. In your perception the color of the shirt should be red, but I am showing a yellow color shirt, so your perception is wrong and you are saying that it is not a shirt. So again I am saying that this is a shirt. So how will you change your perception? The size can be like this, or the shape can be like this. Color can be either yellow or red. Color can be either yellow or red. Again I am showing a small green color shirt. I am showing a small green color shirt and asking that what is this? Will you say it is a shirt? No, because the size is different, shape is same and the color is also different. So I am saying that this is also shirt. So how will you change your perception? Size can be big or small, shape should be like this. Okay, and color can be either red, yellow or green. Likewise, if I am giving more such examples, you are actually learning how to identify a shirt. Okay, this is actually happening in our brain. The same technique is using for machine learning. We are giving examples to the machine and we are making them to learn. Okay, so simply we can say that machine learning is nothing but learn from experience. So mathematically we can define machine learning is the study of algorithms that improves their performance P at some task T with experience E. So machine learning is doing for improving the performance of a particular algorithm for doing a particular task T with the experience E. So you have experience, you have an algorithm and you have to increase the performance. Okay, is it clear? Is it clear? Okay. So what is the difference between traditional programming and machine learning, or what is the difference between traditional programming and learning? In traditional programming, we are actually giving the data as well as the program to the computer, and computer will generate the output. Computer will generate the output. Okay, but in machine learning, we are actually giving the data as well as the output, and we are generating the program itself. We are generating the program itself. In what cases we need to do this type of things? In what cases we need to do this kind of learning? Can you see an example? Is there any real life instances that can be used for machine learning? Suppose in 2011, my salary is 15,000. Okay. In 2012, my salary is 25,000. In 2013, again the salary is 30,000. In 2014, it becomes 45,000. Okay. So we know the years as well as the salary amount. We know the years as well as the salary amount, but we don't know the connection between this year and salary. We don't know the connection between year and salary. If we are observing the salary as well as the year, you can actually find a relation. But how to find that? How to find that relation? In that case, we can use machine learning, because we know the input. Input is the year, salary is the output. We need to find the connection between the year and salary. Okay, so in that case we can use machine learning. We can give the input as year and output as salary. So the computer will generate a program that maps year to particular salary. Okay, is it clear? Fine. So when to use machine learning? In what cases we need to use machine learning? Okay, so the first example is human expertise does not exist. Human expertise does not exist. I will explain it with an example. Suppose we are launching a satellite or a celestial machine to the Mars, and we found a rock there, and we need to analyze what are the chemical components in that rock. What are the chemical components in that rock? Okay, so in that case we cannot reach Mars. We cannot reach Mars. We cannot identify. We cannot find which are the chemical compounds in that stone. In that case, we are actually deploying a robot there. We are deploying a robot, and to work with that robot, it should need some intelligence. That robot should need some intelligence. In that case, for giving that intelligence, we can use machine learning. That is the case of human expertise does not exist. Okay. In the second case, human can't explain their expertise. Okay. Consider an example. One of your friend is calling to a mobile. Okay, one of your friend is calling to a mobile, and hearing his voice, you can identify who is that. How you are identifying it? How you are identifying it? Can you explain it? How will you explain that? How you are actually finding the person at the other end? We cannot actually explain it. Is it right? Okay. In that case also, we are doing it, but we cannot explain it. Okay. In that case also, we can use machine learning. That is, human can't explain their expertise. Then models must be customized. Models must be customized. Consider the scenario that I am entering into a supermarket, okay, and walking, and while reaching a particular store, I am getting a notification that you have this much offer for this product. Okay, so how they are giving that offer? How they are giving that offer? Actually they are collecting my data. How frequently I am visiting this supermarket, what are the products I am frequently buying. Okay, what is the chance of buying a particular product by me. Okay, after finding all those things, they will give a particular offer to a particular product, and that offer is customized to me only. Okay, so there also we have to do some type of learning. So in that case also we can use machine learning. Then what is the last case? Models are based on huge amount of data. That is, in the case of an aeroplane flight, in a single minute, actually that aeroplane is creating terabytes of log data. Suppose there is a crash on that plane, then we should analyze the log data and find out the reason for the crash. Okay, so in a single minute itself we have terabytes of data. So in a 1 hour flight it will be a huge amount of data. So a man cannot manually check the log and find out the reason. In that case we need some efficient algorithms or efficient techniques to analyze the data in a huge volume. Okay, in that case also we can use machine learning. That is the correlation between actually big data and machine learning. Is it clear? Okay. So the last point is very important. Can we do everything with machine learning? Can we do everything with machine learning? No. Do we need to learn for calculating a payroll? Isn't it? No. Actually, learning should be used in a needful situation. Okay, we need not to learn, or the machine need not to learn to calculate a payroll or for a billing system. We can just program it and get the output. So the machine learning should use only when it is needed. Okay, then what are the application areas? That is web search. You all experience this. By typing a keyword, the Google will recommend you the remaining things or give the suggestions for completing your search. That is actually an example of machine learning. Then computational biology. If we have a genomic data, actually that gene data can be stored in 1 or 2 GB of hard disk. Okay, so there's a huge amount of data, and you know that the human and the monkey have only 1% difference in genomic data, only 1% difference in their genomic data. So to analyze what is the difference, we need a high computational power, or as well as we need a better algorithms. In that case we can use machine learning. Okay, now in the case of finance, you know, I think you all know all about stock market predictions. Okay, by using computers or algorithms we can actually predict the stock market value of upcoming days. Okay, and in the case of e-commerce, you are all using Flipkart and Amazon, right? Okay, while buying a phone, the system will recommend that you should buy a cover for the phone or a screen guard for the phone. So how system is doing that? How the Amazon people or the Flipkart people are doing it? They are actually learning. Along with a phone, the customers are actually buying a screen guard or a cover. So for a new customer they can recommend it. Okay, that is a type of learning. And in the case of space exploration, robotics, information extraction, social networks, debugging softwares, in all these areas we can use machine learning applications. So, now the core part, what is actually happening in machine learning? Okay, machine learning can be classified broadly classified into three types, that is supervised learning, unsupervised learning and reinforcement learning. What is it? Supervised learning, unsupervised learning and reinforcement learning. What is supervised learning? What is supervised learning? If you are giving input as well as output to the computer to learn, input as well as output to the computer to learn, it is actually a supervised learning. In that case, we are actually trying to find the relation between input and output. Okay, and in the case of unsupervised learning, we are only giving the input, we are only giving the input and we don't have the output. In that case, what is actually we are going to find? What is the relation between the inputs? What is the relation between the inputs? In the first case, we are trying to find the relation between input and output. In the unsupervised case, we are actually trying to find the relation between input and input, or one input instance and another input instance. And in the case of reinforcement learning, most of the applications of reinforcement learning is in robotics. That is a reward based learning. What is it? Reward based learning. Okay, I will explain it with the example. Suppose you have a robot, okay, and I'm asking to the robot to do a particular task, and he will do it in some manner. Okay, he will do it in some manner. If he is doing that task in a proper way, I will give a good token. Otherwise, I will give a bad token. Okay. Also, if the robot is getting a bad token, he knows that he did it in a wrong way. In the second case, he will try to find another way to do that. So, after getting so many rewards, he can actually find how to do the task in a proper way. Is it clear? Okay. Now, the sub categories in supervised learning, that is classification and regression, comes under supervised learning. What is classification? Suppose we have an input, we have to map that input to a particular group. Map that input into a particular group. That is actually called classification. Okay. Suppose you have an image of a dog, then the system should say that this is an image of dog. Okay. Or else it is an image of cat. That is called classification. Mapping an input into a discrete classes. Then what is regression? Regression, I think you all studied in statistics. Regression and correlation. What is the relation between two independent variables? Okay, that is, I have a particular pressure value, blood sugar value in my particular age, and the next stage I have this much value, and in my 50th age what will be the value of my diabetics. So this is actually finding the relation between age and diabetic value. Okay, so that type of mapping is called regression. Okay, and in the case of unsupervised learning, clustering means if we have a large amount of data, we need to group them according to their similarities. And each group is called actually a cluster. And in reinforcement learning, we have applications in game, learning task, real-time decisions. All these things are doing with reinforcement learning. I think it's clear for you. Is it clear? Okay, so we can recollect. What is machine learning? Learn from experience. Okay, what are the different types of machine learning? Supervised learning, unsupervised learning, and reinforcement learning. Okay, what are the, can you give an example for machine learning in the real life? What is it? E-commerce is an application of machine learning in our real life. In which situations we need to use machine learning? Can you say an example? Human expertise does not exist. Where the human expertise does not exist, we can use there at machine learning.